Cones do more than blocking traffic. At the end of this lesson, you should be able to state the terms and definitions related to a right circular cone, derive the curved surface area of a right circular cone and use this formula to solve problems, derive the total surface area of a right circular cone and use this formula to solve problems, derive the volume of the right circular cone and use this formula to solve problems. All of us have come across objects like an ice cream cone, party cap, and a cone pizza in our daily life. Do these shapes have something in common? We observe that all these figures are in the shape of a cone. So, cone is a three-dimensional solid figure that is in the shape of a pyramid. Now, let us make our own cone. Take a cardboard sheet in the form of a circle. Cut a section out from the circle. Hold both ends and join together such that the ends do not overlap. What is the shape of the figure that you see here? The figure formed is in the shape of a cone. Cones can be of different types. For cones where the line joining the vertex and the center of the base forms a right angle to the base is called the right circular cone, and in this lesson, our scope is limited to right circular cone. Let us observe this cone closely. The fixed point of the top O is called the vertex of the right circular cone. The fixed line OA is called the axis of the right circular cone. Line AB is called the radius of the right circular cone. The circular shape below is called the base of the right circular cone. The line segment joining the vertex to any point on the circular edge of the base is called the slant height of the cone. Let's find the space occupied by the cone. YB can lend us his cap to solve this problem. Let us first find the curved surface area of cone. Take the cap which is in the shape of a right circular cone. Cut the cap along the length of the slant height, say L. Now open it up and spread it on a plane surface. It forms a sector of a circle with radius L. Divide the circular section into small triangles T1, T2, etc. till Tn. We know that the area of each triangle is equal to half into base into height. Area of circular section is equal to the sum of the smaller areas of length L and bases B1, B2, etc. till Bn. Now, let us close this back into a cone. So, B1 plus B2 plus B3 up to Bn is equal to circumference of base circle, which is equal to 2 pi r. Replacing it in the formula, area of circular section is equal to the curved surface area of cone, which is equal to pi rl square units, where r is the radius, l is the slant height. Let us find the total surface area of the cap now. The cap, that is cone, has two parts, the curved area of the cone and the circular base. Total surface area of cone is equal to the sum of the areas of its curved surface and the area of its circular base. We just found out that the curved surface area of the cone is pi rl, and we know that the area of circle is pi r square. So, the total surface area of cone is pi r into r plus l square units, where r is radius, l is slant height. Now, let us find the amount of substance it can hold. Take a conical cup and a cylindrical vessel of the same radius and height. Fill the conical cup with water up to its brim. Pour the water into the cylindrical vessel. Repeat the last two steps till the cylindrical vessel is full up to its brim. Did you count the number of cones of water required to fill the cylindrical vessel? Exactly 3 full cones of water fill the vessel. So, volume of a cylinder is 3 times the volume of a cone. Substituting the formula for volume of cylinder, we get volume of a cone is 1 by 3 pi r square h cubic units, where r is radius, h is the height. Let us solve a real-life situation of finding the area and the cost of canvas required to make a tent in a situation where a conical tent is 10 meters height and the radius of its base is 24 meters. Find the slant height of the tent. If the cost of 1 meter square canvas is Rs 70, find the cost of the canvas required to make the tent. In the given cone, the radius of the cone is 24 meters and the height is 10 meters. Using Pythagoras' theorem of the slant height of the cone is calculated as the square root of the sum of the squares of the other 2 sides. Therefore, the slant height of the cone is equal to OC, which is equal to the square root BC square plus OB square. Substituting the known values of the radius and height, the slant height of the cone is calculated as 26 meters. Since the tent is in the shape of a cone, using the formula for curved surface area of cone as pi RL and substituting the known values and simplifying, we get the curved surface area of the cone as equal to 1961.142 meters square. If the cost of 1 meter square of canvas is Rs 70, then the cost of canvas required to make a tent is obtained by multiplying it with the curved surface area. Therefore, the total cost of canvas required to make the tent is equal to 1,37,280 rupees. The total cost of canvas required to make the tent is equal to 1,37,280 rupees. Let us find the cost of whitewashing the curved area of the tomb in a real-life situation if the slant height and base diameter of a conical tomb are 25 meters and 14 meters respectively. Find the cost of whitewashing its curved surface at the rate of Rs 210 per 100 meters square. The tomb is in the shape of a cone whose diameter is 14 meters and then radius is half the diameter, which is equal to 7 meters. The slant height of the right circular cone is 25 meters. Using the formula for curved surface area of a cone that is equal to pi RL, substituting the values of radius and length, we get curved surface area of the conical tomb as equal to 550 meters square. It is given that the cost of whitewashing per 100 meters square is Rs 210. The cost of whitewashing per meter square of tomb is Rs 2.10. So, the total cost of whitewashing the conical tomb is obtained by multiplying the curved surface area by Rs 2.10, which comes out to be equal to Rs 1,155. So, the cost of whitewashing the tomb is Rs 1,155. Now, let us find the volume and the area of a solid obtained by rotating a right-angled triangle. A right triangle ABC with its sides 5 cm, 12 cm and 13 cm is revolved about the side 12 cm. Find the volume of the solid so obtained. Also, find its curved surface area. It is given that ABC is a right-angled triangle with right angle at B. Here, AB is equal to 12 cm, BC is equal to 5 cm, AC is equal to 13 cm. When this triangle is revolved about AB, it forms a right circular cone of radius equal to BC, which is equal to 5 cm, and height AB is equal to 12 cm. Then, the volume of the solid formed is equal to the volume of the cone of radius 5 cm and height 12 cm. Recall, volume of cone is equal to 1 by 3 pi r square h. Substituting the known values and simplifying, we get volume of cone formed after revolving is equal to 314.2857 centimeter cube. The curved surface area of the solid formed is equal to the curved surface area of the cone. We know that the curved surface area of the cone is equal to pi rl. Substituting the values of radius and length and on simplification, we get the value of the curved surface area of the cone as equal to 204.2857 centimeter square. Let us find the volume of right circular cone that can be fitted into the cube as in the following real-life situation, where it is required to find the volume of the largest right circular cone that can be fitted in a cube whose edge is 14 centimeters. When a right circular cone is to be fitted into the cube, then the diameter of the base of the cone will be equal to the edge of the cone. Then, the edge of the cube will be equal to the diameter of the cone, which is equal to 14 centimeters. Since radius is half the diameter, the radius of base of cone is 14 by 2, which is equal to 7 centimeters. It is given that height of cone is 14 centimeters. We know that volume of cone is equal to 1 by 3 pi r square h. Substituting the known values and simplifying, we get volume of cone as equal to 718.67 centimeter cube. Therefore, the volume of the largest cone that can be fitted into the cube should have a curved surface area of 718.67 cubic centimeter.